In this video we'll look at subtraction and define negative numbers. As always, we first define subtraction and reduce it to addition. It follows that we first have to look at how negative numbers are defined. As we know, there are exactly 16 combinations of 4-bit wide values. We have already defined the numbers from 0 to 15. So the question is, how do we define the corresponding negative values? To do this, let's first look at some well-known calculation rules. In order to be able to define the negative values, we can try it out. We build this circuit and find the appropriate value to satisfy the first equation. With the few values, this can be done quite easily. You find out pretty quickly which values belong together. But we will do this mathematically as usual. First we look for the bit pattern for -1. We write the equation to solve. With our previous knowledge, we can now calculate the values from y0 to y3. You can stop the video and try it yourself. Either way, the solution is this one. This way we find out -1 is 1111. Now let's first look at double negation. It is easy to understand that the double application of non-operation does exactly the same thing. However, simply applying the non-operation does not produce the pattern we are looking for. We need to add another one here. With the same calculation we also get from -1 to 1. At least for 1 and -1 we now have an acceptable calculation method. Now of course we still have to check this procedure. To do this, we solve this equation for all values. In the end we find that the result must always be 0. This gives us a way to trace subtraction back to addition. And with that we could now develop a circuit. Anyone who wants can do this too. However, with the Intel 4004, which is what this video series is about, subtraction works a little differently. And that's why we first have to use another processor as a comparison. And here we take the quasi-successor 8088. This has 4 different instructions. The add command corresponds to the normal addition, while the ADC command, the addition includes the carry. This means that an addition of values larger than, for this processor 8 bits, an add is used first and then the ADC commands. The same goes for subtraction. Here we have the commands SUB and SBB, where SBB is the subtraction with borrow, i.e. the borrowing of the carry. However, the 4004 only has one addition and one subtraction instruction, and these always use the carry. Since this processor only has one adder, this means that it always takes carry into account. Therefore, this means that if you perform a subtraction without a carry set, the result does not correspond to the subtraction. And the subtraction from 0 corresponds to the non-operation of the second value. So at this point I'm just going to create a 4-bit NOT. We take this command on the command line and then go into the generated script. The calculate method is written using combiner, splitter and NOT. Of course, the fast method always makes this shorter. Now we create the finished circuit. If you want, you can write a test script for this. In the next video we'll look at incrementation and decrementation.